Hello and welcome back, everybody. Let's take a look at AP Chemistry Unit 5. And this electrochemistry unit is a little bit further in their textbook. It's actually in chapter 17 and a little bit brings in some 16 as well. But the reason I'm bringing it up now is because it has to do with building off of Unit 4, where we learned a lot about redox reactions. And so just kind of tying it in there, we'll do an introductory with what is electrochemistry, and we'll take a look at some things with some fun labs and everything. But essentially, the reason I'm bringing it in now is because we've been just talking about chemical reactions, taking a look at the chemical energy that's involved in there, and we can actually translate that to electrical energy as well. And so we do that through two types of cells. This first unit is our section is going to be all about the voltaic cells, and you'll see with voltaic cells we can quantify the electrical energy in terms of volts. And you can see here these are all examples of redox reactions, aren't they? Half reactions within the redox. And so you can see what's going on with this and why it would be pretty logical to bring from the redox reactions right to these types of cells. There is another type of cell out there that we'll talk about later, electrolytic cells, and that is basically using electrical energy to force a non-spontaneous reaction. We'll talk about what that means in terms of should the reaction go or will it go in this unit as well. So that's why it brings in a little bit of chapter 16 stuff with it. But if we take a look at voltaic cells themselves, this is the first unit. Taking a look at voltaic cells, we've got to wrap our head around some concepts. And so the concept is this: if I have an oxidation going on, remember that is going to be a more something that becomes more positive along the way. That's what we refer to as an anode on our batteries. And so if we take a look also following up with our reduction, we see that it's going to be gaining more and more. Again, think back to our oil rig. Okay, so gaining and losing electrons. If it's going to be gaining more electrons, we refer to that thing as a cathode. Okay, so let's analyze this in terms of this particular scenario. Let's say we have a zinc metal, and we put that into a copper 2 chloride solution. Okay, it's a solution in there, so it's going to be aqueous. And the question is, what's going to be happening? Even in Gen Chem, we do this type of thing. We call this a single replacement reaction. And I'm going to get zinc chloride in there, and I'm going to get copper metal. Okay, but let's think about this in terms now that we know a little bit more about how all this works, let's look at this in terms of a redox reaction. I have any solid is going to be a zero charge. This is going to be a -1. This is a +2 for oxidation states, -1, +2. So what's really going on here in terms of a redox is that we see my oxidation is going to be the thing that's getting oxidized is going to be my zinc because it's going into zinc metal. I'll just ignore the chlorine off of here because that's going to be a spectator ion anyway. And notice with that, I'm going to be generating 2 electrons to go with it. Okay, and so if I take a look also at my reduction end of things, I could see that my copper ion, again, this is going to be a spectator, so I'm not going to worry about them. If I gain 2 electrons here, gain those electrons, it's going to be forming my solid, which is a 0. Okay, so that's going to be a simple way of taking a look at that. And if we were to actually apply that along the way, that I'd see that my copper is going to be have a voltage on there of a 0.339. And I just use a chart to look at these things. That's what I'm referencing here. And that I see that my zinc is going to be a negative 0.62 or 762 voltage. And so it's a pretty simple way to analyze those things, again, just using a chart. Now, if I'm going to apply this piece as well, notice that my oxidation thing, this is going to be my anode. Okay, my zinc is being my anode, and my copper solution would be considered the cathode. Now, I'm just right now thinking of my zinc that's being a metal that's submersed in or immersed in 1 copper ion and 2 chloride ions floating around in solution. And so what's happening is my zinc is forming the solution of zinc ions, and my copper is actually forming onto the metal itself. And I'm, in a sense, basically going to be plating my zinc with the copper. Okay, that's my anode, that's my cathode along the way. I can abbreviate all of this information. I can abbreviate all of this. The abbreviated cell reaction would just be saying that my zinc is forming a zinc ion, and on the other end of this, so that's going to be my anode, and even though I've got only one thing in here, I do have a cathode on there as well. And so my cathode is the part that's getting reduced, and that's going to be my copper ion is going into copper. Okay, so it's a reduction, and this is my oxidation end of things, and this is my reduction end of things. Okay, so that means this is my anode and this is my cathode. Okay, so that's how all that works in terms of a redox reaction when you have a metal that's just being placed within a solution. Okay, now we can do something even more with that. We can go a little bit more complex, and we could go within and take two pieces of metal. And so let's do that. Let's take a look at what's happening. Same type of scenario on here, but now let's say that we have the zinc metal and a copper metal, and we'll make a complete circuit. And so to make that circuit, we combine these two metals with a wire, and we do have to have something for the circuit, what we refer to as a salt bridge. Now, when we say salt, we tend to think of something like sodium chloride, but it doesn't have to be. Anything that's readily ionic, and so we see that we have a sodium ion and a chloride ion that's readily available. Okay, so let's take a look at what's happening here. We said that my zinc was going into solution, and that my copper was going on to the metal. Okay, now remember that this was my anode and this was my cathode. And now we're starting to see something that's even more like a battery when we have a positive side and a negative side. In fact, we could put a little voltmeter on here and we can measure those electrons as they're going. Now remember that the zinc itself is going to be losing electrons along the way. Okay, it's going to become more positive. Where are those electrons going? Well, they're going up this entire wire, and they're going down into my copper. Okay, and so that's part of it. So how is that circuit going to be completed? Well, I've got the direction of those electrons, but remember, here's my salt bridge. If this is going to be the electrons going down into this side, that means that my sodium is going to be attracted to this side, or going to be more functional on this side. My chloride is going to be the thing that's going to be allowing the electrons to be accumulating, and so we can now keep combining this entire circuit. Okay, so that's how we would analyze something like this in terms of a true battery where we don't have just one thing in solution, but I have two things and I can combine the sides with a cathode and an anode along the way. Cool. Now we're going to be taking a look at some more applications of this. Okay, so here's a scenario where we take chlorine gas bubbled through a water solution of sodium bromide, and it's a spontaneous. That'll come into play a little bit later of what I mean. This is not the exact same example as what's being outlined, but you can see we have the anode here. We're going to be bubbling up that gas, and so essentially the equation that we're seeing, it looks like this. Okay, so that's the scenario that we've got going on here, and we have to do some tasks with this. We want to draw the cell. We want to see what's the cathode, what's the anode, and all of this, which way things are going, basically all the things that I've shown before. So I'm going to cheat because my drawings are not the best. So I'm cheating in that I've set up this voltaic cell in the first place. Okay, let's take a look and we'll draw the voltaic cell. We have our metals and so on. But before I can label what's on there, we've got to analyze what's going on in the equation. I have, these are going to be zero charges. This is -1. This is a -1 here. So what's happening is that my chlorine is going to be the thing that's going to be reduced in this case. Okay, so the reduction end of things, notice that my chlorine is going to be gaining 2 electrons, and it's going to become the 2 chloride ions. And then my oxidation end of things, my 2 bromines, ions, I should say, bromide ions, are going to be forming the bromine gas, and to do that, it will be giving off 2 electrons. Okay, so what's happening along those lines is my bromine is becoming more positive, and my chlorine is becoming more negative. All right, so what does that mean as we go back over here? Well, if I have something that's not going to be reacting, I have just the bromine itself that's down here and my chloride that's in here. I've got to go with a metal that's not going to be involved in the reaction. I'm just going to be taking a look and bubbling these things up. So we tend to use a metal that's not going to react or be a part of it. And that metal, a lot of times, is going to be something like platinum, very non-reactive. And so what's happening in here is my two bromines, let me switch colors so you can see it better. My two bromines, ions, are going to become the bromine liquid. And then similarly, I have my two chloride ions are going to become the Cl2 gas. Okay, so it's going to be bubbling up and I'd harvest it from there. We have a salt bridge that's going to be causing this to go. So let's use, in this case, let's use something like potassium nitrate. It could be anything that gives up those particular ions very readily. Now we have all the things that we need to label up our voltaic cell. Notice that we've got the solutions. I put an inert metal in there, and we can say now the thing that's getting oxidized. Okay, the thing that's getting oxidized is going to be my bromine. And so that makes this my anode side, doesn't it? The thing that's getting oxidized is my anode. The thing that's getting reduced is going to be my cathode. Okay. And so there we've got the oxidation as the anode, and we've got that. Now, if it's going to be losing those electrons, remember which direction those are going to be going. AP College Board always asks these types of questions. Show which way the electrons are going. We can actually put a voltmeter right in the middle of this to measure that flow of electrons. And so let's see what happens with my salt bridge. Well, if I've got to put my electrons down here, they've got to make their way back over, don't they? And so have my electrons here. I've got to have my potassium on this side, and my nitrate is going to be active on this side. We have ourselves a full circuit that goes all the way through for my voltaic cell. Notice that I've labeled up my cathode, I've labeled up my anode, I've gone through and I've indicated which direction my electrons are going, and we also talk about where the anions move and the cations, and I did that within my salt bridge. So I have all the components that I need with that, and if no solid is listed in the reaction, just remember, there's no solid in this reaction at all, select something that's non-reactive. I use platinum all the time with that, and that'll facilitate the reaction without it being a participant in any of those things along the way. Okay, so that's how that works. Let's take a look at another example, and we'll do the same thing as before, and we're going to take now, we do have a metal, and this is going to be zinc, and we're going to be taking it in the presence of hydrogen ions. Okay, so we're going to do the exact same thing in here. Let's label up our components. First of all, we've got to figure out who's my redox in all of this. Okay, so this is a +1, and this is a +2. Okay, so you can see now that my zinc is going into a zinc, that's a +2, and my hydrogen ions, I have two of them, my hydrogen ions are going to be gaining electrons and becoming H2. So if it's gaining, that's going to be reducing, and here's my oxidizing agent. Okay, and so let's label up our components all the way around, and in this case we do have a metal, and so that's going to be my zinc metal. Okay, this side we don't want reacting, and remember what metal we use if we don't want it reacting? It's platinum. Remember that we have the hydrogen ions that's in there, and that's what we're going to be taking a look at. So what happens, because it's going to be oxidized here, I have my zinc is going to become my zinc ions, and I have my hydrogen ions that's going to be the hydrogen gas. Okay, this is my cathode because it's being reduced, and this is my anode because it's being oxidized. Now remember, if this is going to be happening, the electrons are going to be moving in this way. And we can measure that using a voltmeter. We can measure that, that electricity as it goes. And I could use anything. If I use sodium chloride, I'll just use potassium nitrate again. And remember that if this is my negative side, this is my positive side. To facilitate that, I've got my different components. Okay, so again, just going through and identifying those different components, I see my electrons. I see that this is going to be forming into the solution. I've labeled my cathode and anode. I've identified which directions they're going, and I've done my anions and cations. Okay, I've got all the components I needed for that particular type of question. I guess I could do an abbreviated portion of this, that my zinc will form into the zinc ions with a double slash of my hydrogen ions forming into the hydrogen gas. That's about all that I can do with those types of problems. So to summarize all of these things, voltaic cells consist of two half cells. They're joined by the external electrical circuit, and we see that salt bridge. Make sure you include that salt bridge along the way. Each one will consist of an electrode dipping into the water solution. And so you'll see some questions. What happens if the solution dries up? What happens if there's no contact? And so on. You broke your circuit. And so if a metal participates in that one, either as a product or a reactant, it's ordinarily used as the electrode. Otherwise, you put something inert like platinum. Okay, and in those, oxidation happens. Now, you've got to keep this drilled in mind that your oxidation is the anode and reduction happens at the cathode. Okay, with that being said, you should be able to go through the first set of problems with that, and I wish you guys well.